Hello students, I think you are doing well. Today we are going to read about Unit 9 of Science and Technology of Grade 10, and here it is the continuity of the lesson. Before it we have done different contents related with it. Before it we have discussed about specific heat capacity as well as heat capacity, yes, and in that lesson we discussed that the amount of heat required to raise temperature of 1 kg mass of a body by 1 degree Celsius is specific heat capacity of that substance. If you are told that what is understood by the specific heat capacity of mercury is 140 joule per kg degree Celsius, then here what do you mean by specific heat capacity of mercury is 140 joule per kg degree Celsius? It is the question. In that condition, you have to explain this relation, and here you have to say that it means that 140 joule heat is required. It means that 140 joule heat is required to raise the temperature of 1 kg mass of mercury by 1 degree Celsius. So, in definition, it is explained. Same thing we have done in that definition of a specific heat capacity, isn't it? So, that thing you have to mention. Similarly, about other substances you can explain. What is meant by specific heat capacity of water is 4200 joule per kg degree Celsius. Joule per kg degree Celsius. In the same pattern you can say, it means that to raise the temperature of 1 kg mass of water by 1 degree Celsius, we need what amount of heat? 4200 joule heat. Or if 4200 joule heat is given to 1 kg mass of water, then its temperature is raised by what? 1 degree Celsius. So, that thing you can, if you have understood, you can explain it anyway. Yes. So, main thing is you have to understand it. Yeah. Okay, friends. So, before starting today's lesson, we have to think once about a question. What is shown here? It is gun. Gun is gun, but another type of gun. It is thermal gun. Yes, you have seen it now that it is used to record temperature of a person. Yes. So, how do thermal guns measure temperature without touching the body and the objects? Generally, we have used the different type of clinical thermometer to which we have to keep in the contact of our body, either in armpit or under the tongue. Yes, but this instrument is not touch the body. Yes, just by passing a ray, that ray I think you are familiar with it, that is infrared. Yes. So, here is sensor of that type in it which receives that signal and converts it into what? Temperature. That means the real temperature is shown on this display. Yeah. Okay. So, in detail, not so detail, but little bit we will study about it. But before doing about thermometers, we have to discuss about some uses of specific heat capacity in our daily life, about which you were given work to do, that was project work. Yes. So, have you seen that drivers use water in the radiator of the vehicles? Yes. Some other coolants are also mixed in with water, that is another thing, but main thing is water there. Why water is used in the radiator? You know that in the known substances, maximum specific heat capacity is of water. That's why water changes its temperature by absorbing more heat. It has very high capacity of what? Absorbing heat. Yes. So, water is used for cooling and heating, both the purpose. If cold water is used, that cools the substances in the contact of which it remains. And if hot water is used, that provides heat to the bodies in the contact of which it is. Yes. So here cold water is used in radiators and it cools the hot engines without significant change in its temperature. Okay, that is due to which property? Yes, maximum specific heat capacity of water. And because of same property, you have seen that in hot water bags, yes, name is hot water bag, so certainly water is filled in it. Hot water is filled in it. And you have seen its use? Yes, it is used to heat our body parts. Yes, maybe abdominal region, maybe leg, sometimes knee, sometimes waist. Yes, so they are heated by using what? Hot water bags in which hot water is kept. Region is same. It has more specific heat capacity, so it can provide heat for longer time. Consider you have no hot water bag. Can you use any local material? Yes, you can. Glass bottle can be used. You can use glass bottle, but remember that by heat the bottle should not be cracked. Yes. So if it's okay, then tight the lid, wrap in cloth and use to heat. You can use that as what? Heating agent. Okay. Now next one is, yes, the baby is sleeping. What happened? Here is wet cotton gauze. So that is as coolant. That is cool to human body. If a person is suffering at very high temperature, then at that condition, wet cotton can be used on his her forehead, then that may be rubbed on palms and then on the sole of leg, and other body parts also can be wiped by using what? Wet cloth. So that wetness, that water absorbs more heat of the body and the temperature falls down. Have you done ever it? It is very common. Yes, before taking medicine or after taking medicine also it can be done. Yeah. Okay. Now next one is, oh, how interesting scenario. Yeah. So here it is shown that it is ocean and it is land. And during day, look here, the sun is wearing goggles. Yeah. So just cartoon is given here. So here during day, due to the sun's heat, which one will be heated at first, the land or the water? Students, keep one thing in your mind. If you know that water has maximum specific heat capacity, then if any other substance is compared with it, then that will have what? Less specific heat capacity. You also know that those substances which have more specific heat capacity, they change their temperature slowly because they can absorb more heat. And those which have less specific heat capacity, they change their temperature faster because they do not have more retaining capacity of heat, more absorbing capacity of heat. Absorbing capacity, you can say. So here out of land and water, as water has maximum specific heat capacity, so during day, which one will be heated at first? Certainly land. And when land is heated, air above it is heated. Hot air become lighter, they move up. Then their space remains. Vacuum is not formed. In that condition, the air which are above ocean at high density, because they are colder, they are not as hotter as the air above the land, because seawater is not going to cool very fast because its specific heat capacity is more, isn't it? So that cold sea breeze moves towards the land. So sea breeze occurs during day. Do you understand why sea breeze occurs? And look here, here convection current is formed. One question was given last time, that specific heat capacity of water forms convection current. So there is role of water and land both. So there is role of specific heat capacity mainly, which forms that what? Current. Okay. And just opposite situation becomes at night. What happens at night? See here. At night, in the lack of sunset, both lose their temperature, both become cooler and cooler. That substance which has less specific heat capacity gets colder earlier, that cools earlier. So here land becomes cooler and sea becomes what? Warmer. And in this condition, the air above the ocean is warmer, so it rises up. And the air above the land is what? At high density, at low temperature, and that moves towards the what? Sea. Now it is called as land breeze. So sea breeze occurs during day and land breeze occurs during what? Night. Yes. So that's why the direction of wind changes during day and night in coastal region. Okay. And here that ocean water also plays role in the weather condition in the surroundings. During the day, the land gets heat, land is heated, land is warmer. During day, no problem, that may be more heat. At night, the ocean nearby it, sea nearby it does not cool so fast. It cools slowly, and you know that there is huge amount of water in ocean. So it takes very long time to be cooled. That means it is warmer at night. So this warmth is passed to what? Land. That means in coastal region, the temperature does not fall so down. Remember it. That is the fact. Why in coastal region people do not need, especially I am not talking about the polar region, in our, that means in Asian countries, or you can say just like in India, Sri Lanka, yes, Philippines, in these countries, the persons near ocean do not need any warm cloth to wear in winter. They do not feel so that means so extreme winter in winter season. So extreme cold in winter season. Due to what? Presence of ocean. Okay. So that also you can relate with it. Yeah. Okay. So there were some advantages of specific heat capacity, some effects of specific heat capacity which occur in our daily life. So I think many of them you have done as project work. Yes. Okay, students. Now we are going to discuss about measurement of temperature. We have discussed about heat, temperature and thermal energy. Yes. And we know that temperature is measured by using what? Thermometers. Yes. So here are thermometers. All these thermometers are used with liquid. This thermometer is clinical thermometer that is used with mercury. Another thermometer is alcohol thermometer. So I will show you. This thermometer is here, alcohol thermometer, already you have seen. Here is alcohol thermometer. Yes. So it is here thermometric liquid is alcohol. Okay. That is maximum minimum thermometer which is used to measure maximum and minimum temperature of the 24 hours. And here I am not going to discuss about its working method, but you should know that thing, that during maximum temperature the indicator moves up and remains at a point. It does not fall down itself. But when the bulb which is filled with partially alcohol, there is vacuum, here is vacuum, here is alcohol, it is filled with alcohol. And when that is cooled, then what happens? The alcohol contracts and it pulls the mercury towards it. So here this indicator moves up. So in 24 hours, one indicator shows maximum temperature, another temperature shows minimum temperature. That is maximum minimum temperature. So these thermometers are used with liquids and they are called thermometric liquids. And you know that what are used as thermometric liquid? Either alcohol or mercury. Yes, only these two materials are used as thermometric liquid. Okay, another thermometer is digital thermometer. I also have digital thermometer with me. So that is digital thermometer. Look here. This is digital thermometer. Here is thermistor. That is thermistor. Here is display. Here is switch. And under this lid, there is battery. Under this lid, there is what? Battery. Yes, that supplies electrical energy to work to function this instrument. So when we have to use it, we have to switch on. We have to switch on. Then the number displays. So here it is displaying, yes, something is displayed. And when we touch it or when we keep it for 1 minute in that means under our armpit, you know how does it measure? After recording the temperature, it beeps. Yes, so here is speaker also to beep, and after that we take it out and find out the temperature. So here main thing is the thermistor. Yes, that helps to measure temperature. Yes, it is digital one and especially used as what? Clinical thermometer. Okay. Now next one is radiation thermometer or infrared thermometer. You have seen that is thermal gun about which the question was asked. Yes. So here is sensor of infrared. Infrared sensors are here. So on the basis of infrared radiation, this thermometer works. Yes. To measure the temperature, infrared is passed to the object or to the person's body, that may be on the person's forehead or on the person's that wrist. There also it can be measured. Yes. And after that the sensor changes, or here is some transducers are also found which change one type of energy into another type, and the temperature is displayed here. We can read the temperature. It is radiation thermometer. Okay. Thermometer may be of any type, students, doesn't matter. But they should be calibrated, and especially those thermometers which are used with thermometric liquid, they are calibrated. Yes, that means we have to find out to certain points. By dividing the range between the certain points, we have to make scale on it. In fact, what is calibration? Calibration is the process of making scale on a newly constructed thermometer. So here we are not constructing any thermometer, just we have constructed thermometer with us. So here we will understand how calibration of thermometer is done. Consider the thermometer I am using is not calibrated, then how is it calibrated? Yes? Okay. So what is calibration of thermometer then? During construction of a new liquid thermometer, scale has to be made on it. Yes, we have to make a scale also, otherwise how can we know that what is the temperature by using it? Yes, for making a scale, lower and upper fixed points are required. Remember, what are the points? Lower fixed point and upper fixed point, 2 points. About these points we will discuss later. Process of determining lower fixed point and upper fixed point in a newly constructed thermometer is calibration of thermometer. So the process of determining these 2 points means lower fixed point and upper fixed point. As I told you, we will discuss that. What are they? Don't worry. So that is the process is what? Calibration of thermometer. After calibrating the thermometer, the range between the 2 points is divided in particular equal parts to make a scale on the thermometer. That depends on the type of scale you are going to make on your thermometer. If you are going to make Kelvin thermometer, that means Kelvin scale or Celsius scale, in both cases the range is divided into 100 equal parts. And if you are going to calibrate Fahrenheit scale, that going to make Fahrenheit scale after calibration, then you will divide the range in between what? 180 parts. That's why here it is given that divided in particular equal parts. Maybe 100 or 180. If 180, that will be helpful to measure what temperature, in which scale? Yes, that will be in what? Fahrenheit scale, degree Fahrenheit. and if that is divided into 100 equal parts, that will be helpful to measure in which scale? Kelvin or Celsius, degree Celsius. You understand? Okay, students. Now we will do some practical activities, and after that only I will mention about some text related with it. So for that experiment, I am going to use this set. Here is an empty beaker, nothing in it. Here is funnel in which I will keep ice cubes, and inside it I will adjust one thermometer. Let's see how it is going to be done. Okay, students. So here that empty beaker is taken just to collect the melted ice. Here is ice cube in funnel and glass funnel, and I am adjusting the thermometer. Before adjusting the thermometer, you can read the reading. What is it? Is it clear? Is it clear? Yes, 25, 26 room temperature. Yes. Now I am placing it. Okay. Now leave it for few minutes. Okay, students. Here the thermometer is kept in the ice for few minutes only. Just you can see what is the temperature. Yes. If you are pasting here the scale and you are marking that point, it will be 0 degree Celsius. Yes, you can see clearly that is what? 0 degree Celsius. Yes. So in this way, lower fixed point is found in a newly constructed thermometer. After that, we will find out upper fixed point in the same thermometer. Okay, students. Now you see here how the apparatus is set. Here a round bottom flask is taken with water, and here the cork used in it has two things. One is tube, glass tube, another one is thermometer, and that thermometer is showing temperature about 25 degrees Celsius. So I will show you, look here near my finger, because it is not alcohol thermometer, it is just shining. So here you can find out in between 20 and 30 the mercury level is. Yes, and here I am adjusting inside the flask in such a way that the bulb is not touching the water, because we have to measure the temperature of steam. Yes, and then by using a split lamp we are going to heat it, and you have to wait till the water boils. Okay, students, just see water is near to boil. Yes, some bubbles are forming, and here temperature is also probably increased. Look, yes, water. Yes. So what is the temperature in this condition? You have to see. In fact, the thermometer is not inside the water. It is not showing the temperature of boiling water. Steam is formed. Clearly you can see steam is coming out. At that condition, what is the temperature? Just see. Yes, that is near about 100 degrees Celsius. It is near about 100 degrees Celsius, not completely 100 degrees Celsius. Can you say why? What is its cause? Because this experiment is done at height. We are in Kathmandu Valley, that is about 1000 meter high from the sea level. As height increases, air pressure decreases, and at low pressure, the boiling point lowers. Okay? So it is slightly less than 100 degrees Celsius. Okay, students, now see what is lower fixed point and how is it determined. Already you have done just the sentence. The apparatus, yes, in the same way you have set funnel with ice cube, and then below the funnel an empty beaker which was in which water, melted ice was collecting in the form of water, retort stand. Yes, and here is thermometer. In fact, we are using already calibrated thermometer, just finding out really that lower fixed point is 0 degrees Celsius and upper fixed point is 100 degrees Celsius or not. Yes. For it, The temperature of melting ice or freezing point of water at standard atmospheric pressure, means at sea level, is lower fixed point. Yeah, its value is 0 degrees Celsius at sea level. If height increases, slightly its value also changes. Lower fixed point is determined by placing the bulb of a newly constructed thermometer in melting ice for a few minutes as shown in the diagram. So, you have already done it. Yes, and you found that it is what? 0 degrees Celsius. Yes. Now, what is upper fixed point? For upper fixed point is temperature of steam at sea level. Yeah. To find out it, here I was not using bent tube, I was using just straight tube, doesn't matter, to pass out the steam. The newly constructed thermometer is kept in the flask. That flask is round bottom flask we are using with water, and the bulb of the thermometer is kept above water level. Above what? Water level, because it has to measure the temperature of steam, and then it is heated by any source of heat. Other things are here clear in the diagram. Yes. So, what is upper fixed point? The temperature of steam at standard atmospheric pressure or at sea level is upper fixed point. Its value is 100 degrees Celsius at sea level. Yes, we have found near about 100, slightly 19 less. Upper fixed point is determined by placing the bulb of a newly constructed thermometer in steam as shown in the diagram. Already the condition is explained. Yes. So, by finding these 2 points, consider you have found these 2 points on a thermometer. It was a newly constructed, we are imagining that it is newly constructed thermometer, and here we found 2 points. One is lower fixed point, how much? 0 degrees Celsius, maybe Fahrenheit, how much? 32 degree Fahrenheit. In Kelvin, it may be what? 273.15, but we do not mention 15, leave it. 273 Kelvin. Yes. So, that is what? Lower fixed point. Yes. And here upper fixed point is boiling point of water, or you can say steam, temperature of steam at sea level, that is 100 degrees Celsius or 212 degree Fahrenheit or 373.15 Kelvin, but we write only 373. So, after finding these 2 points, this range is divided into, if it is divided into 100 equal parts, then we get what? We make what? Which scale? For degree Celsius and Kelvin. And if the range is divided into 180 parts, that is for what? For degree Fahrenheit. Yes, it is clear. The same thing I will make you clear by another diagram. So, here the range is divided into particular equal parts, you have to keep in mind. For degree Celsius and for Kelvin, how many parts? 100 parts. And for degree Fahrenheit, in how many parts? 180 parts. Yes? Okay. Okay, students, now see the last slide. It is comparing different temperature scale. Look here, that is for Kelvin. Here Kelvins, here is water freezes, that is melting point of ice is how much? 273. We used to say 273, and here water boils at what? 373 in Kelvin scale. In Celsius scale, 0 degrees Celsius and 100 degrees Celsius, these 2 points are. And in Fahrenheit scale, 32 degree Fahrenheit is lower fixed point and upper fixed point is how much? 212. Body temperature is also compared here, normal body temperature. If a person is not suffering with fever, then in degree Celsius, 37 degrees Celsius. in Fahrenheit 98.6 Fahrenheit, and in Kelvin 310.15, or you can say 310 Kelvin. Yes, and one term is absolute zero, about which we mentioned when you were given the concept of thermal energy. So, absolute zero is in fact 0 Kelvin, and that is equivalent to minus 273 degree Celsius. Here I am neglecting that point, and minus 450.5 what degree Fahrenheit. Yes. So, absolute 0 here 5 instead of 6 7 I am saying 0.5. So, that is for your EG. So, that is the comparison of these three major different scales. But here mainly you have to understand about upper fixed point and lower fixed point in it. Is it clear? Okay. Now, one project work is given to you in which you have to make a chart showing the process of calibration of thermometer. So, how is lower fixed point and how is upper fixed point determined? These things you have to show in diagrams. Yes, that is your project work. Now, before asking you that that about different questions to know your understanding, at first just remind the things we have studied. We discussed about different events which are based on different specific heat capacity, especially the use of more specific heat capacity in our daily life we discussed. Because of it, water is used in heat radiators. Because of it, water is used in hot water bags. Because of it, water not only in hot water bags, inside our body also the water supports to maintain the body temperature, sometimes by sweating, sometimes by, that means absorbing heat inside our body. Yes, inside our body also the taken water, in the water which is taken in, that also helps to balance what? Our temperature. Yeah. So, in different ways, how can we use the specific heat capacity of water in our daily life we discussed. Then we discussed about different type of thermometers in SART, and finally we discussed about calibration of thermometer, in which the lower fixed point and upper fixed points are determined in newly constructed thermometer. Yes, students. Okay, here are some questions about which you have to think and answer. The question first is, what is the effect of the specific heat capacity of water? Sea water heats faster than coastal land during day. Is it? Sea water remains hotter than coastal land during night. Coastal land remains hotter than sea water during night. Sea water and coastal land both heat at the same rate during day. Which of them is related with the specific heat capacity of water? The fact, so very easily you can guess it. Sea water remains hotter than coastal land during night, because sea water or water has more specific heat capacity. It takes longer time to be cooled, so it can retain more heat in it. Yes. Okay. Now next, what is the lower fixed point of the thermometer in different scales? 0 degree Celsius, 0 degree Fahrenheit and 0 Kelvin, or 0 degree Celsius, 32 degree Fahrenheit and 273 Kelvin, or 0 degree Celsius, 180 degree Fahrenheit and 373 Kelvin, or 0 degree Celsius, 212 degree Fahrenheit and 273 Kelvin. So, easily you have guessed it. Yes, that is the P number, 0 degree Celsius, 32 degree Fahrenheit and 273 Kelvin. Okay, students. Next question is, what is the purpose of calibration of thermometer? Why is calibration of thermometer is done? To test thermometer scale, means the scale is true or not, to check it, or to measure temperature of melting ice and boiling water, or to make scale a new thermometer, or to compare different scales of thermometer. So, here new thermometer means newly constructed thermometer. It does not mean that when you are buying a new thermometer from market. newly constructed thermometer here. Yes. So there are 4 alternatives. In your opinion, which one is correct? Yes, it is to make a scale on newly constructed thermometer. Yeah. Now, next number question is, which statement of following is true about calibration of thermometer? Temperature of boiling liquid is upper fixed point. Temperature of steam is considered as upper fixed point. Temperature of boiling liquid at sea level is upper fixed point, or temperature of steam at sea level is upper fixed point. You have to think about all of them. Yes, slightly different. So yes, you can get easily, that is the last one. Temperature of steam at sea level is upper fixed point. Yes, steam is, that is vapor, water vapor. Okay, students. Now here are some questions to which you have to copy and write answer of them to show your teachers. Yeah. So first question is, define calibration of thermometers. Very easy question. Yes. Next, differentiate between lower and upper fixed points in 2 points. Only 2 points. So very easily you can write difference and then values. Yes. Next, describe in short about determination of lower fixed point. So about whole process which was done in experiment, you have to mention here step by step. You can do with diagram. Okay. Describe in short about determination of upper fixed point. Same thing about upper fixed point as you did in question number 3. What is the role of specific heat capacity of water in forming land breeze and sea breeze, about which we discussed? Clarify with suitable diagrams. You have to simplify the diagram, not necessary to make the cartoon as shown. Yes. So you can make your own symbolic diagram, doesn't matter. Next one, last one. What will happen if a person is using oil instead of water in hot water bag to heat his body parts? Understand the question? The person is not filling hot water in that hot water bag. He is making hot oil bag that. Then what will happen? That means what will be the problem, what will be the advantage, everything you have to discuss here. Is there advantage? Then you have to mention. Not advantageous. What may be there? You like, you have to write your opinion. Okay, students, I think you enjoyed today's class. In next class, I will come with something new, unit, new lessons. That's all for today. Namaste.